Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to start a new way of graphing polynomials, but not any polynomial, or not just polynomial, but many functions that we are going to call them the parent functions. Why do we call them parents? Let's see. So I'm going to write here parent functions. And we are going to define a parent function is a function, y is a function of x, but it doesn't contain any numbers. What do you mean by that? I mean that if I say the easiest polynomial function would be y equals x. I don't say 3x or 2x minus 4. No, just y equals x. You know that this is an equation of a straight line that has a slope of 1, meaning 45 degrees. So if I'm going to plot it on the first graph on the left, I will have like 3 graphs or 6 per page, and we'll see how many we are going to do. So x and then f of x or y, a function. Okay, all of these are f of x's. The first one we are going to draw is y equals x. So I know that it has a slope of 1, meaning I go 1 to the right and 1 up, or 1 to the left and 1 down, and it looks something like that. I don't want to go very low because I will have another function here. So y equals x. And as you can see, if I do a quadratic, it would be y equals x squared, right? No 3, no minus, no plus, nothing. So 0 and 0, 1 and 1, 2 and 4, 3 and 9 would be above. So we'll get something that looks like that. And this is y equals x squared. If you remember, y equals x is odd. And since x is positive, the right-hand side goes to infinity. And because it's odd, the left goes down to negative infinity. Square meaning both are the same. And since it's positive x squared, meaning a is 1, they go both up. When I do y equals x cubed, well, again, the right-hand side will be going up, but the left-hand side will be going down. And again, 0 and 0, 1 and 1, 2 and 8. So it would be going very up right there. And negative 1 would be negative 1. Negative 2 would be negative 8. But I don't want to go down here. Let's see, 2, 3, 4, 5, 6, 7, 8. And it's going to go something like that. See, here is the turn, and then it's going to turn the other way up. And of course, y equals x to the fourth would be similar to that. And as I told you last time, I will have like a band here. So it doesn't go directly. Again, this one wasn't plotted carefully. Again, unfortunately, this is a pen, not a pencil, so it's not easy. But if it's x to the 4, it would stay very close to the x-axis for a while, and then it goes up. Okay? Same thing with x to the 5th. But these are the polynomials. Okay? Now, when we move to a new set of equations, we have the exponential equations. In fact, you can use 2 to the x, 3 to the x, any number, and you say, oh, you said no numbers. No, I meant outside of the, so it's not like 4e to the x or e to the x minus 5, or you see, or negative e to the x. No, it's just e to the x. So in that case, I know that when x is 0, e to the 0 is 1. When x is 1, e squared, e to the 1 is 2.7 something, so it would be 2.71, something like that. And when it's when it's negative, when you go to negative infinity, you see that the x is an asymptote. The x-axis is asymptote, so it goes something like that. And then it starts going up like this. So this is, for example, y equals e to the x. I also have y equals natural log of x. We haven't covered natural log yet, but or the log functions. But we are going to do that soon. So the natural log, you cannot have a natural log of a negative number. So it would be on the positive side, and negative zero, I'm sorry, natural log of zero is negative infinity. So the y-axis here is an axis of asymptote. Okay? Now, natural log of 1 is 0. So 1 and 0 is a point. Natural log of e, which is 2.7, somewhere here, is 1. And you can see that it's going to go something like that. Oops, I went so far. So, okay. So y equals natural log of x. Okay, let's move to the next page. And I'm going to plot more of the parent functions. Okay, I want you to really memorize these, but it's not memorization. When you work with these functions a lot, you get to know it by heart. Just by looking, you would see. Okay, the new one is the absolute value. Absolute value meaning it spits always a positive number. So y equals absolute value of x, meaning when x is positive, I get 1, 1, 2, 2, 3, 3, 4, 4, like y equals x, exactly like y equals. But when y equals negative 1, instead of getting negative 1, I get back positive 1, positive 2, positive 3, and it looks like the letter V. That's, again, I think the paper is not really, or these squares are not having the same size, but it looks something like that. This is the absolute value of x. Next, we are going to look at y equals the square root of x. I know you cannot have a square root of a negative number, so when x is negative, I'm not going to get anything. But here we have a problem. How? Notice the square root, we call it the principal root, meaning the positive part. So when I say y equals square root of 4, I get 2, not plus or minus 2. You know why? Because if I get plus or minus 2, it's no longer a function. Remember we said for a function, every value of x is having a unique value of y. I cannot have multiple values of y. So if I say square root of 4 is plus or minus 2, so which one is it? It also, let's do it and then we'll see. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. So it goes something like that. If I do it and negative 1 and negative 2 and negative 3, and do you see what happens? It fails the vertical line test. So I have to do it only this branch. How about the cube root? The cube root of x. Now the cube root can be positive or x can be positive or negative. Cube root of 0 is 0, of 1 is 1, of 8 is 2. But cube root of negative 1 is negative 1, and cube root of negative 8, 1, 2, 3, 4, 5, 6, 7, 8 is negative 2. So it goes like, and of course, of negative 27 would be 3. It goes down, but very slowly. It's, curving up, then curving down, and it will go increase to infinity. Now, what else can we do? I think these are the most important. These 9 are the ones. And then, of course, you have the trig functions. We'll do them in a special section, like sine, cosine, and tan. You know how to plot them, but we are not going to touch on these for now. Because what I want to do in our next session is remember when you did the transformations in geometry? So you learn translation, you learn reflection, you learn dilation, and then you learn rotation, which we are not going to worry about for now. I don't know why Claude is updating. Anyway, so, oh my God, what's happening? I'm sorry, guys. So we will see how we are going to get these algebraically. And the method I use, I can claim I developed it, but after working with many of these transformations, I found that the way they are described in the books doesn't make perfect sense. It doesn't teach you how to do it. It's like you have to memorize a set of equations, or not equations, set of rules. And when we address the x, it's the opposite of how we address the y. I worked on it until I think I got it in an easier way that I hope you like it. I will present it to you next time. And we'll see how we use the transformation without the rotation. The rotation is like a little more advanced if you rotate about any angle. I have some videos that discuss that in the mathematics playlist, but it's beyond the scope of this course. So we are going to just restrict ourselves to what you are going to learn. What I also want to touch on is the inverse functions. Remember we said before that, for example, the inverse of operators, inverse of addition is subtraction, so plus and minus, times and divided by, square and square root. So let's look at these. Do you see the square? Of course, the square has 2 branches because you can have a square of a negative number. But the square root, we had to say, no, just the positive number. So if you look at this branch, just this branch, the positive one, and that branch, do you see something? Notice I'm going to draw it, not draw it, just it goes something like that. And this is like that. Do you see something very interesting? Is that this line y equals x is an axis of symmetry for these 2 inverse functions. This one is going up and to the right. This one is going down, like this is going up and this is going to the right. It's like they are 2 branches. If I place a mirror here, I see the picture of this red or magenta line as the blue line, if it's drawn perfect. Same thing for the cube and the cube root. You see the cube and the cube root. So if you want to draw, just show the cube, look something like that. And then here it goes down like that. Again, y equals x would be an axis of symmetry. Exponential and log. If I say y equals x, would look something like that. And these are 2 images of the same graph. And it turns out that this is always the case. So for two inverse functions, they are symmetric around the line y equals x. Okay, so that's something nice to know, but it doesn't help us with what we are going to cover next time, which I told you, we are going to look at graph transformations, translations, dilation, and reflection. So until then, I wish you all the best, and I hope to see you soon. Bye.